So, I am going to talk about performance and scaling. Now, performance is not only of benefit to you as an end user or as an administrator of a Nextcloud server, but it also helps our planet. Using less resources lowers the CO2 emissions caused by the nearly 500,000 Nextcloud servers on the internet. Now, faster can mean a few different things. First, of course, is the end user experience. When loading an app in your browser or when you're using it, you have to wait, and you don't want to wait. So, loading less would reduce your wait. So our developers worked on a tool that puts together the JavaScript in a way that the file sizes get smaller, and therefore your loading time can get up to 5 times less when checking out Nextcloud apps. So sometimes you can make things faster by just not doing some things, like changing the code to not set up the file system when a guest accesses a public link, or by simplifying queries done to access sharing information, like that was done in Deck for this release. Another change we did was to make loading data smarter. For example, in the Tables app, when you import or edit a very big table, we load data incrementally to avoid long waiting times. And sometimes you need a much bigger architectural change to improve performance. In 2021, we introduced our high-performance backend for files. We designed the high-performance backend after we saw that at the TU Berlin, the clients, both web and mobile, were sending over 16,000 requests every minute to the servers, simply to check in to see if there had been any changes or any notifications. Now, this accounted for over 2/3 of the network traffic. And the high-performance backend replaces these checks by simply keeping a connection open, hugely reducing the load these checks cause on the network by up to 90%. Now, the high-performance backend reduces your network traffic significantly, but it has another benefit: instant notifications. Say you're in a call, you want to, of course, get a notification right away, and this is what the high-performance backend makes possible. Now, over the last few months, our engineers also added support for the high-performance backend to Nextcloud Text. Now, Nextcloud Text is a real-time collaborative editor. You use it to work together with other people on notes or, brainstorm session, etc. And it uses a polling mechanism to send data between the clients. Now, using the high-performance backend, this is not only a lot faster, it also reduces the load on the server by up to 90%. So those improvements, they benefit you as a user directly and also lower the load a bit on the server. But we did more to lower loads on the server. For example, Nextcloud Text now also reduces the speed at which it updates text in an open document when the user has no editing rights. It's less work that way, and the impact is negligible. We also made context chat smarter, the feature that Marcel talked about earlier, by handling the indexing of files as well as the removal of them from the index in a way that uses less resource. Now, the second major thing we did for the server is to speed up the update process. This could on large systems really take quite a while, and we moved some steps out of the update process into cron and eliminated some other steps. We also created a tool for an admin to get information about the database changes that will be needed for an upgrade, which then gives the administrator a rough way to estimate how long the update might take. Now, you wonder, okay, so what was the impact of these changes? Now, we tested this on a very large system, and it took 2 hours to do an update. So that means 2 hours of downtime. Now, after the changes, this went down to 5 minutes. So the update time went down by over 95%. Now, of course, not all updates will be impacted this much, but it's certainly promising for administrators running really large instances. Now I covered how Nextcloud is snappier for users, how it reduces the load on the server, updates faster, but there's a whole other side to performance, and that is scalability. Now, Nextcloud already scales from very small devices like a Raspberry Pi all the way up to big Kubernetes setups that can handle millions of users, like for example done at Magenta Cloud from Deutsche Telekom here in Germany. Now, sometimes you want to handle even more users, and for that we have our unique global scale architecture. It allows tens of millions of users on a Nextcloud service by running distributed over several data centers that can even be on different continents. One example of such a setup is the Claro Drive service of América Móvil. This service is designed for over 20 million users, distributed in 4 different hosting centers in Central and South America, and they're doing this using Nextcloud Global Scale. Now, we always work to improve scalability even more, and Well, with this release, we've been working further on database sharding. That's something we started on last time. Database sharding means that the Nextcloud database can be split up in several smaller databases to distribute the load between different servers. We introduced the base for sharding in the previous release and build upon it to allow sharding now to work for most use cases. Another huge architectural improvement that we did was improving the read after write behavior of the database. Now Nextcloud required synchronous replication, which limits the number of database cluster nodes to 4. We now support an unlimited number of read nodes that are using asynchronous replication. This improvement, together with database sharding, moves the scalability of Nextcloud to a next level, supporting up to 10 times more users for a single cluster. So, concluding, we improved performance all the way up and down the stack. We shortened the load times of apps by reducing their size. We made Nextcloud Text more responsive using the high-performance backend. And we reduced the time for updates, improving database abilities for very large instances.